Okay, so now let's discuss modifying values with fancy indexing. So just as fancy indexing can be used to access parts of an array, it can also be used to modify parts of an array. For example, imagine we have an array of indices and we would like to set the corresponding items in an array to some value. X is equals to np dot range, and now I is equals to np dot array 2184 2184 I print x. This results in, okay, so we can use any assignment type operator for this. We got the result. For example, here is the code. Got this. So notice though that repeated indices with these operations can cause some potentially unexpected results. Consider the following, like this: np dot zeros x. Four comma 6 print. Okay, so notice that though that repeated indices with this operation can cause some potentially unexpected results, you can consider this. So where did the 4 go? Have you noticed that? So the result of this operation is to first assign x0 is equals to 4, followed by x0 is equals to 6. The result, of course, is that x in the square bracket 0 contains the value 6. Fair enough, but consider this operation is equals to square bracket 2, 3, 3, 4, 4, 4, 3, 3, 4, 4. So we got this. You might expect that x3 would contain the value 2 and x in the square bracket 4 would contain the value 3, as this is how many times each index is repeated. Why is this not the case? Conceptually, this is because xi plus is equals to 1 is meant as a shorthand of xi is equals to xi plus 1. X in the square bracket I plus 1 is evaluated, and then the result is assigned to the indices in X. With this in mind, it is not the augmentation that happens multiple times, but the assignment which leads to the rather non-initiative results. So what if you want the other behavior where the operation is repeated? For this, you can use the at method of ufuncs, which is available since numpy 1.8, and you can do the following like this: x is equals to np dot so the at method does an in place application of the given operator at the specified indices, here I, with the specified value here 1. Another method that is similar in spirit is the reduce at parenthesis method of ufuncs, which you can read about in the numpy documentation. Okay, so let's go to the example.